Hello class 9. In this video I'm going to cover up the MCQ portion of chapter 1. So I suggest you watch this video till the end so that you can go through all the questions along with me. Exercise 1.1. Now here in the first question we have, which of the following statement is true? The first option is minus 3 by 8 lies on the left of 0 on the number line. And second option is 5 by 9 lies on the right of 0 on the number line. And C, the rational number 1 by 2 and minus 2 by 7 are on the opposite sides of 0 on the number line. Now the last option is all the above. Okay, on the number line, 0 is here. You know that on the left side it is minus 1, minus 2, minus 3 and so on. And on the right hand side you have plus 1, 2, 3, 4 and so on. So here let's see the first option. Now the first option says minus 3 by 8 lies on the left of 0. So here, because of this minus, we come to know that okay, this particular number lies to the left of 0. So this statement is true. And the second statement, 5 by 9 lies to the right. Okay, so here 5 by 9 is positive, which means it lies on the right side of 0. So this is also correct. And C, the rational numbers 1 by 2 and minus 2 by 7 are on the opposite side. Okay, this is plus, this is minus. So plus, then it is on the right side, minus, then it is on the left side. So since they are on the opposite side, this statement is also true. So which means all the given statements are true. So our answer should be all the above. So our answer is, solution is all the above. All the above. And now let's move on to the next question, question number 2. A rational number between x and y is, I'll give you an example, 6 and 8. Now 6 is a rational number, 8 is also a rational number. Now if we want to find out a rational number between 6 and 8, then what we need to do is we will simply add these two numbers and then you divide by 2. Then this is 14. Now here we get 7. So this 7 lies between 6 and 8. So in order to find one number between any two given number, we simply add the two number and then divide by 2. So if we have to find between x and y, then we will add x and y and then we will divide by 2. So this is our correct answer, which is option number 3. So solution is option number C, x plus y by 2. Okay, now question number 3. Okay, how many rational numbers are there between minus 5 and minus, say this is minus 5 and this is minus 4. Now we know that between minus 4 and minus 5 there will be minus 4.1, minus 4.2 and so on. Again, between this minus 4.1 and 4 you have minus 4.01, minus 4.02 and so on. Again, we can find out rational number between these two. So it will be minus 4.001, minus 4.002 and so on. So if we continue like this, it will keep on going. So that means there are infinite number of rational numbers between any two numbers. So the answer is infinite number. So option D. So solution is option D. Okay, next we're moving on to question number 4. A rational number between 1 by 4 and 1 by 2 is 3 by 4, 3 by 8, 3 by 5, 2 by 3. Okay, this is Similar to question number 2, as I have explained, if you want to find any rational number between any two given numbers, then what we need to do is we will add the two number and then divide by 2. Now here let's take LCM of 4 and 2 is 4. So here you will get here 4 divided by 4 is 1, 1 into 1 is 1, plus 4 divided by 2 is 2, 2 ones are 2. So what we got here is 3 by 4. Now this is equal to, now this is 3 by 4, and then this line I'm going to write it as divided sign by 2. Now if you change this divided sign into multiplication sign, then you will get here upside down. You will change it into upside down like this. Now you will get here 3 ones are 3, 4 twos are 8. So this is our solution. So the correct option is B. So the solution is B, 3 by 8. Now question number 5. A rational number between -2 and -5 is, so you're going to add this two number by 2. The two given numbers are -2 and -5. So what we do here is we will add this two number and then you divide by 2. So here we get -2 plus minus is -5 by 2. Now this is -2 minus 5 is -7 by downside denominator we have 2. So this is our solution. So -7 by 2 is C. So solution is C, -7 by 2. Now let's move on to the next exercise, that is exercise 1.2. Here the first question is, pi is an natural number, integer, rational number, irrational number. Now the value of pi is, I have written down here, pi is 3.1415926535 and so on. Now what we observe here is it does not, no digit is repeating. It's not a repeating decimal representation, and moreover it does not end. That means it does not terminate. So such numbers are called irrational numbers. So our answer is going to be irrational number. So option D is our solution. Irrational number. Irrational number. Now question number 2. To represent square root p, where p is a positive integer on the number line, we first represent. I'm going to take an example here. Let's try to represent square root 5. Now how long this particular line segment is, you will measure with your compass, and then when you do like this, then you will get somewhere here. Now this represents square root 5. Now while drawing this, in order to get square root 5, you have to go through all this. You have to first draw square root 4. So only after that you can find out square root 5. So this means that if you want to find the square root, let's say x, then first thing you have to do is you need to find out x minus 1 first, p minus 1. So this is our right option. So solution is square root p minus 1. Now we're moving on to question number 3. Square roots of positive integers are rational, irrational, either rational or irrational, neither irrational nor irrational number. Okay, to understand this, let's say square root 3. Now this 3 is a positive integer. Now square root 3 is irrational number. because it is 1.71. It keeps on going without ending, without terminating. Now next we'll take an example of square root 4. Now this 4 is also a positive integer, but here in this case square root 4 is 2, which is a rational number. So here in this case it is irrational, in this case it is rational. So sometimes we make it rational, sometimes we make it irrational. So the answer is either rational or irrational. So this is our right answer. So C, either rational or irrational. Now question number 4. On the number lines, root 7 can be located after locating. Okay, this is similar to question number 2. So if you want to locate square root 7, then you have to first locate square root 7 minus 1, square root 6, that is 7 minus 1. So this is our solution. So the solution is 7 minus 1. Okay, now we're moving on to exercise 1.3. And the first question is, the decimal expansion of the number root 2 is a finite decimal, this one, non-terminating, repeating, non-terminating, non-repeating. Okay, the value of square root 2 I have written down here. Root 2 is 1.414213562. So it keeps on going without repeating and without ending. So obviously this is an irrational number. So here it is non-terminating, it does not end, and moreover it does not repeat. So the answer is going to be non-terminating and non-repeating. Our answer is non-terminating, non-repeating. This is the correct option. And now question number 2. The value of 2.999 in the form p by q, where p and q are integers, q not equal to 0 is, okay, here 2.999, and this is a non-terminating decimal representation, but it is a repeating one because here 9 is repeating. So in short we can write 2.9 par here, which means 9 repeats. Now in order to represent this in the form p by q, I'm going to use the shortcut here. The shortcut is whatever number you have here, you write it here. Now this is, forget about the point and the par, so take the number here, this is 29, minus, and take the digit which is not under par. So under par is 9, 2 is not under par, so here 2, and then how many digits are under par? If there are 2 digits, then you write here 2 9. If there are 3 digits, you write 3 9s. If there is only 1 digit, then you will write only 1 9. Now since there is only 1 digit repeating here, so we write only 1 9, irrespective of what number here. For you should not worry about the digit here, number here. So now 29 minus 2 is 27 by 9. Now this one we can cut, 9 3s are 27, so the answer is 3. So our solution is C. C is equal to C is 3. This is our solution. Now question number 4. Question number 3. The decimal representation of a rational number can be terminating, non-terminating, repeating, all the above. Okay, terminating. Okay, this is okay because a rational number should be terminating. That is one condition. And another condition is, even though it is not terminating, it should be terminating and non-terminating, non-terminating, but it should be repeating and repeating. So these are the two very important points for a number to be a rational number here. So it says terminating, that is fine. Non-terminating, repeating, that is fine. And here B, non-terminating and nothing is given here. So it can be true also, because here it is not mentioned. It has no. It is not mentioning that it is non-terminating, non-repeating, non-terminating, repeating. So we still consider this as a valid solution, valid option. So we have 1, 2, 3. So which means our answer is all the above. So solution is going to be all the above. All the above. Now question number 4. An irrational number between 0.3101 and 0.333 is okay. Now for our convenience, we will let us consider only 2 digits after the decimal point here. So 31, here 33. So between 31 and 33, you can there are many. So let's check which one is between 31 and 33. Here 32, because we know that 32 is between 31 and 33. So this must be our right answer. So solution is here 32, 0.320100100001. So this is our solution. Now question number 5. 1.54 par when expressed in the form P of P by Q, where P and Q are integers and Q is not equal to 0 is. Okay, this question is again similar to question number 2. So here our number is 1.54 bar. Now, as I have explained earlier, we're going to use shortcut. So the shortcut is you write the number here. Don't worry about the point and the bar. So just write here 154 minus. Now what you're going to write here is you're going to see the digit which is not under the bar. So under the bar is 54, so without bar is 1. So you're going to write here 1 divided by, now under the bar there are 2 digits, so we're going to write 2 nines here. If there are 3 digits, you will write 3 nines. If there is only 1 digit, then you will write only 1 9. So 154 minus 1 is 153 divided by 99. Okay, so this is our answer. So 153 by 99. So this is the correct option. D, 153 by 99. So this is our solution. Now question number 5. 0.25 is equal to similar question. So 0.25 par. As I've said just now, you write whatever number is here. So you write here 25. 0. No, we don't need to write 0 here. Minus. Now the digit which is not under the par is 0. So you can write here 0. And there are 2 digits below the par. So you're going to write 2 nines. Now 25 minus 0 is 25 and 99. So this is our answer. So this is the right option. B, 25 by 99. Let's move up on to exercise 1.5. Okay, the first question. The product of a rational number and an irrational number is always an irrational number, always a rational number, always an integer, sometimes rational and sometimes irrational. Okay, to understand this, we will take an example. Okay, 0 is a rational number and root 2 is irrational number. Now if we multiply this 0 into root 2, we get here 0. So this is rational number, this is irrational number. So product of rational and irrational, we are getting rational here. This is rational, this is irrational, rational. So this is rational here. Now again another example. Okay, 2 into root 3. Now this is rational, this is irrational. Now what we got here is 2 root 3. This is irrational. So in the first case, rational, irrational, then we're getting rational. And in the second case, same, rational and irrational, we're getting irrational. So sometimes we're getting rational, sometimes we're getting irrational. So this is the right answer. Sometimes rational and sometimes irrational. But in your textbook, backside answer, it is given always irrational number. So that is okay. Now question number 2. On dividing 12 root 12 by 3 root 3, we get, okay, so these are the option. Now here in this case, we're going to divide 12 root 12 by 3 root 3. Now this one you can write 12 by 3 into root 12 by 3. Now we can write like this because this is square root, this is also square root. Now you cannot do like this if the order is different. That means if this cube root and if this square root, or if this fourth root and this is square root. But in this case both these are square root, so you can write like this. So here 3 1s are 3, 3 4s are 12, 3 1s are 3, 3 4s are 12. Now what we got here is 4 root 4. Now again 4 root 4 is 4 into root 4 is 2, so which is 4 2s are 8. So this is our answer, option A. Solution is A. Now question number 3. The product 8 plus 3 root 2, 8 minus 3 root 2 is a rational number, an irrational number, neither a rational nor an irrational number, none of this. Okay, so we're going to multiply this. 8 plus 3 root 2, 8 minus 3 root 2. Now in this case I'm going to use shortcut, and you have to recall this: a plus b, a minus b. So if you get like this type of numbers, multiplication of numbers, then you will always use this formula. This is shortcut of multiplication. So a square minus b square, this is the formula that you have been learning from the lower classes. Now a plus b, a minus b is a square minus b square. Now 8 square is 64. Now this 3 root 2 square, this square is for 3 as well as root 2. So 3 square is 9 into root 2 square is 2. So you have here 64 minus 9 2s are 18. Now 64 minus 18. Okay, this is 6. 5 minus 1 is 4. So 46. This is 46. Now this is a rational number. So our answer is going to be the first option, that is A, a rational number. So solution is a rational number. Now question number 4. If a and b are natural numbers, then a plus root b into a minus root b is a rational. This is exactly same as question number 3, similar to question number 3. A plus root b, a minus root b. Now this is a plus b, a minus b is a square minus root b square. So you get here a square minus square. This is cut already, so this is a rational number. And next is question number 5. If x is equal to 2 plus root 3, then x minus 1 by x is equal to this. Okay, so here we have x is equal to 2 plus root 3. Now since x is equal to 2 plus root 3, then 1 by x will be 1 by 2 plus root 3. This is a very simple logic. Now x is equal to 5, then 1 by x will be equal to 1 by 5. Okay, now what we are going to find here is x minus 1 by x. X minus 1 by x. Now here x is 2 plus root 3 minus 1 by x is this one. But before we put this value here, let's simplify this. We will rationalize the denominator. 1 by 2 plus root 3 into, now this is plus, so I'm going to write here minus 2 plus root 3, here 2 minus root 3. Whatever you have written here, the same thing you have to write here, 2 minus root 3. Now if you multiply 1 and this one, you will get 2 minus root 3, and in the denominator a plus b, a minus b, so it is in that form. So a plus b, a minus b is a square minus b square. So what we got here now is 2 minus root 3, and 2 square is 4, minus square and root cut, so you have here 3. Now finally what you got is 2 minus root 3 divided by 1, which is nothing but 2 minus root 3. Now this is the value of 1 by x, so instead of 1 by x, I'm going to write this 2 minus root 3 here. Now this is equal to 2 plus root 3 minus 2, minus minus is plus root 3. Now 2 minus 2 is 0. Now root 3 plus root 3 is 1 root 3 plus 1 root 3 is 2 root 3. So this is how we got the answer here. Okay, next question, question number 6. 1 by 4 plus root 5 is equal to, okay, these are the given options. What you have to do here is you just need to rationalize the denominator. 1 by 4 plus root 5 into, now there is plus here, plus sign, so we will simply change the sign here, root 4 minus root 5, rationalizing the denominator. So whatever you have written here, you have to write the same thing up here. Now this is equal to, now numerator 1 into 4 minus root 5 is 4 minus root 5, and then in the denominator we have 4 plus root 5, 4 minus root 5, which is in the form a plus b, a minus b. So the formula is a square minus b square. So you will get here a square, that means 4 square, and b square, that means root 5 square. Now numerator will remain the same. In the denominator 4 square is 16, and square and root cut, then you have here 16 minus 5. Now this gives us 4 minus root 5 upon 16 minus 5 is 11. So this is our answer, which is given in 4 minus root 5 in this. Now let's move on to question number 7. After rationalizing the denominator of 7 by 3 root 3 minus 2 root 2, we get the denominator as, okay, so here also we're going to rationalize the denominator. 3 root 3 minus 2 root 2 7 by 3 root 3 minus 2 root 2 into, okay, this is minus, so we will write plus here, and the same thing you're going to write up here. Now numerator is 7 into this, so you write the same thing here, 3 root 3 plus 2 root 2, and then in the denominator it is again a minus b, a plus b form, so a square minus b square, so 3 root 3 square minus 2 root 2 square. Now this gives us, numerator remains the same, and the denominator is, this square is for both 3 and root 3, so 3 square is 9, root 3 square is 3, minus again here also 2 square is 4 into root 2 square is 2. Now numerator just leave it as it is. Denominator now is 9 3s are 27 minus 4 2s are 8. Now this gives us 7 3 root 3 plus 2 root 2. Now 27 minus 8 is 27 minus 8, you get here 19. So here in the final expression that we get here, the denominator is 19. So this is our answer. Now let's move on to exercise 1.6. The first question is, the value of 343 to the power minus 1 by 3 is equal to. Okay, so here we have 343 to the power minus 1 by 3. Now 343 is divisible by 7. So 7 4s are 28, 6 3, 7 9s are 63. So 7 7s are 49. So we have here 7 cube. 7 cube to the power minus 1 by 3. Now this is equal to, now you have to multiply powers and power. Power and power you have to multiply. Now here we can cut. So what we get now is 7 raised to the power minus 1, which is simply 1 by 7. So B is the correct answer. Now question number 2. Root 32 divided by root 2 is equal to. Okay, root 32 divided by root 2. Now this is same as this. So since the order of the root is same, so you can write together like this. Now you cut 2 1s are 2, 2 1 6. So we get here root 16, which is equal to 4. So B is the answer. Now next is question number 3. The value of 16 raised to the power minus 1 by 4 into 4th root of 16. 16 to the power 1 by 4 into 4th root of 16. Okay, this is equal to, 16 is 2 to the power 4. 2 4s are 8, 2 2s are 4, so 16 is 2 to the power 4, 1 by 4. Again this one you can write 16, this 4th root is nothing but 1 by 4, so you have here 2 raised to the power 4 into minus 1 by 4, and here also 16 is 2 to the power 4, 1 by 4. This is equal to 4 cancel out, so you have here 2 to the power minus 1, and here 2 to the power 4 into 4, 4 into 1 by 4. Power and power you have to multiply. 4 ones are 4, 4 ones are 4, so you have here 2 raised to the power minus 1. It simply means 1 by 2, and into 2. Power is 1 here. Now you can cancel out this, and now what we got here is 1. So C is the answer. Now let's move on to the next question. Next question is 2 raised to the power 4 by 3 is same as 2 raised to the power 4 by 3. Now this can be written as 2 to the power 4, power is 4, and okay, before this you can write like this, 4 by 3, you can write 4 into 1 by 3. So this one is 2 to the power 4, you can write like this, 1 by 3. This is nothing but 4 into 1 by 3. Now this 1 by 3 is nothing but cube root 2 to the power 4. So cube root of 2 to the power 4. So C is the answer. And now question number 5. Question number 5 is here we have cube root of 2 square, and here we have 4th root. This one, let us start from this 2 square innermost, so 2 square, and now this is cube root, so cube root is 1 by 3, and here 4th root, so again we have here 4th root 1 by 4. 4th root is 1 by 4. Now you have to remember square root of some number, let's say 2, is 2 to the power 1 by 2, and if it is cube root of 2, then it is 2 to the power 1 by 3. If it is 4th root of 2, then it is 2 to the power 1 by 4. If it is 5th root, it will be 2 to the power 1 by 5, 6th root to the power 1 by 6, and so on. So now here you have to multiply the power here, 2 into 1 by 3 into 1 by 4. Now 2 ones are 2, 2 twos are 4. Now what we got here is 2 raised to the power 1 by 3 twos are 6. So 2 to the power 1 by 6. So this is the answer. Now question number 6. Cube root of 64 raised to the power minus 1 by 2. Cube root of 64 raised to the power minus 1 by 2. Like I said, cube root is power 1 by 3, and we have another 1 by 2 here. So here 1 by 2 minus 1 by 2. Now this will be equal to 64. Let's multiply the power. 1 by 3 into minus 1 by 2. Now this gives us again 64 is 2 to the power 6. So 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4. So 1 2 3 4 5 6. So 64 is again 2 to the power 6. And here plus minus is minus 1 by 3 2s are 6. Now in the next step Again we will multiply these powers. 6 into minus 1 by 6. Now 6 and 6 we can cut. Now we get here 2 to the power minus 1, which simply means 1 by 2. So 1 by 2 is our answer. So this is the answer. Now question number 7. Okay, on simplifying x to the power a minus b into x to the power b minus c, we get, okay, now x to the power a minus b into x to the power b minus c, x to the power c minus a. Okay, let's leave the denominator for now. And denominator here, the base are same. The base is x here. So if the base are same and if this is multiplication, then we have to add the power. So x to the power a minus b plus b minus c. So what we got here is x to the power, here minus b plus b is 0. Now we get here a minus c. A minus c, and in the denominator we have x to the power c minus a. Again here numerator and denominator, the base are same, x. So since this is division, we have to subtract the power. So x to the power a minus c minus c minus a. Now this is equal to x to the power a minus c minus minus is plus a. Now what we get here is a plus a is 2a, and minus c is minus 2c. Now x to the power, you can take 2 common here, you get a minus c. So this is our answer, which we get in D. So these are right option. Now let's move on to question number 8. Which of the following is equal to x? Okay, so these are the options. Now here the answer is C. Now how the answer is C, I will show you. Now here C is root x cube raised to the power 2 by 3. Now here root x cube. Now square root is 1 by 2, 2 by 3 here. Now let's multiply the powers. So here 3, here 1 by 2, here 2 by 3. Here now we can cut 2 ones are 2, 2 ones are 2, 3 ones are 3, 3 ones are 3. So we get here x to the power 1, which is nothing but x. So this is the answer.